Hey there, students. Um, hey there, students. This video is all about the quick checks. So let's make sure you got them down. Also, this is your opportunity to go, hey, wait a minute, Mr. Montoya made a mistake. I know it. I said it never happens, but yeah, I lied. If you find one, just let me know. All right, here we go. Skills check. Now, I think in the original video or the instructional video, I said there was something unique about this skills check and a special reason I wanted you to do it. Um, One, for most of your mathematics life, if somebody asked you for the square root of something, they were simply asking for the principal square root, and that is the positive square root. So for like number one, the square root of 36, you know that one of the answers could be negative 6, right? Negative 6 is also the square root of 36. And if we went back to factoring polynomials, we knew that was an issue, right? If we had a trinomial and the last term was plus 36, we knew that when we factored, our factors could be negative 6 times negative 6, or they could be positive 6 times positive 6. And then we looked at the sign of b to tell us whether or not the factors of 36 were going to be positive or negative, right? So we already knew. We already knew that we should consider the negative value of a square root. However, now we're going to explicitly um, evaluate square roots with both their negative and positive version, but after this skill check. So in the skill check, number one, they're just looking for positive 6. Number two, you see the negative in front of the square root. That's one way to indicate that we're looking for just negative 9. We don't care about positive 9 in this case. Um, and then I'll just let you double check them all for there from there. I will tell you this: be mindful of your decimal place, and what I mean is number 4, number 5, and number 6. Remember, when you move a decimal place, one place value, that is a multiple of 10, right, or a factor of 10, and the square root of 10 is an irrational number. But when you move that decimal two places, you are changing the value of the number by a factor of 100, and the square root of 100 is 10. And here's why that's important. 25 has a square root of 5. 0.25, like here, number 5, has a square root of 0.5. 2.5 doesn't have a rational square root. It's an irrational number because you only move the place value, the decimal place, one unit. So you only change the value by a factor of 10. And because that factor of 10 doesn't have a rational square root, 2.5 doesn't have a rational square root. Kind of a little extra lesson in the skill check. Coming down here to fractions, you will learn a lot of these rules of radicals in the next unit. Um, but we can take the square root of the numerator, square root of the denominator, and we come up with 1/2. Same thing here with 1/9, and same thing over here with 7/10. Again, we're not looking for plus or minus because they didn't ask for it. The reason plus or minus is here is because they asked for it here. All right, enough of the skill check. We are looking at quick check one, solving by graphing. Now, here, if we're solving for the roots of a function by graphing, um, I'm sharing a lot of information here to show you how I conceptualized graphing this function. Okay, I didn't just start picking numbers and making a table. What I did was I changed the quadratic equation to a quadratic function because you graph the function, you don't graph the equation. The equation is represented by these 2 points here, or the solutions are represented by these 2 points here, but the function is the entire graph itself, right? I identified the y-intercept right here as -1. I identified the axis as x equals 0 because we have 0 for a b value here, and therefore the vertex is going to be where the y-intercept is because that's where the axis is. So y-intercept's at -1, vertex is at 0, 1. That's the first one that I graph. I knew that this was going to be an upward shape because this is a positive a value. Therefore, I knew I was going to have two roots. That's why all of this is here. If you didn't write that, that's fine. But what I'm trying to show you is that this is what you should be thinking about as you graph quadratics. Where's my axis? Where's my vertex? What's my shape? All right. We see the solutions are both positive and negative 1. And of course, if we substitute those into our quadratic equation, we will get 0. Number 2, here's the graph. Again, same thing. Y-intercept positive 4, axis x equals 0, vertex at 0, 4, shape is U. I knew immediately that because my vertex was above the upward facing U. Because my vertex was above the x-axis and my shape was a positive in the positive direction, I knew I wasn't going to have any solutions. I honestly didn't need to graph this with this information and a little bit of reasoning. However, I use this information to graph it, prove that I don't have any solutions. Okay. Notice that because of this planning, I knew I was going to need a different scale for my y-axis. My x-axis scale does not have to have the same scale. In fact, if I made this too big, the y value would get too big too fast. So I needed to make sure that my x-axis stayed at a scale of 1 so my curve didn't get out of control. All right, but I knew because I had an a value of 2 that this was going to be narrow, which means that the curve increases very quickly. So I knew I needed a scale that was going to be able to handle that. All right. Quick check 1, number 3. All right. Here they don't give you the form in the form. They don't give you the equation in the form of the quadratic equation, so you have to manipulate things a little bit because we don't have an equal 0 here. Add 16 to both sides, and we end up with x squared equals 0, which then gives us the parent function, x squared equals y. Kind of a boring one if you ask me. Y-intercept of 0, vertex of 0, 0, upward shape, axis is on the y-axis. We get our parent function. We only have one solution, x is 0. All right, sound good? That's quick check 1. Quick check 2. Quick check 2 using square roots. So now no graphing involved. I am just showing every single step. If you didn't, no need to redo it. I'm just trying to show you that it's going to be important showing every step. When you are in geometry and you're doing proofs, showing all of your work and noting the postulate. Ooh, test my vocabulary from geometry. Um, and the rules that you're using to validate your proof is really important. So that's what I'm doing here. All right, so we add 25 to both sides, take the square root of both sides. Here we are looking for both the positive and negative value. So the solutions in this case are t equals 5 or negative 5. Both of those will give us an output of 0. Over here, we subtract 12 from both sides, divide by 3, n squared equals square root of 0. We only have one solution because the square root of 0 is just 0. All right. Next one, you can imagine we only had one other option, and that's no solution. Here we're going to subtract 32 from both sides. We have a negative number over here. Divide both sides by 2. We have a negative number over here, and 16. Oh, that feels so good as far as square roots go. You really want to say 4. But it is the square root of a negative number. So 4 times 4 will not give us negative 16, and negative 4 times negative 4 will not get us 16. We will need to use an imaginary number to show, to simplify this further. All right. Yes, there is an imaginary number. If you remember studying all of your number classifications, it was the set of real numbers. And in the set of real numbers, we had subsets. Irrational numbers and then rational numbers, and then rational numbers had a whole bunch of subsets. But what you might not have noticed is that just adjacent to the set of real numbers was a little tiny box called imaginary numbers, right? Imaginary and complex. So anyway, complex, yes. No solution. All right. Now I put in parentheses here, no real solution, because as far as in the set of real numbers, no, there's not a real solution to this problem, but you'll learn later that you have other options. Quick, quick check 3. Quick check 3, real world scenario. We are, oops, I better, okay. I was leaning on my microphone off button, so I was about to flip out. Anyway, let's get here to quick check three. We have a real world situation. We have a cylindrical, if I remember, city fountain, and the volume of that fountain right here as I list out our givens. Yes, I am listing out our givens. It is an important part of the process when solving equations in real world scenarios. So we have capital V, that's going to be our volume, 1800 cubic feet. We have H, the height of the inside of the cylindrical fountain is 3 feet, and we are asked for the radius. They give us the volume equation. So volume equals pi r squared times 3. Substitute in parentheses just in case. In order to isolate r squared, I divide both sides by 3 pi. After I divide both sides by 3 pi, what in the world? Why do I have 1600 times pi? I mean, 600 times pi. Oh, that's horrible. What is going on? No, that should be 600 divided by pi and the square root of 600 divided by pi. You know how I would have known that this answer is incorrect? I would have substituted this answer like you should back into the original equation and I would have tested it out. So this is wrong. This should be 600 divided by pi. I can do the 1800 divided by 3, no problem. Simplify that to 600. But that pi should be in the denominator. Should be in the denominator. So I'm not going to remake this video. I am going to go ahead and let my mistake sit there and stare me and you in the face for a little bit. And why don't you share in the class comments what the correct answer for quick check 3 should be? How about we do that? Okay, so that is the quick check video. I hope that was helpful, and I hope you watched it even though you thought you didn't need to, because I do try to throw a little extra instruction in there for you. All right, sounds good, guys. Keep it up.